Okay, welcome. So fascinating keynote from Stefan about the future. This one is a little bit of my story, also my take on the 30 years of Java. And it's going to be interesting because I'll go back to the past. So it's 1995, and imagine there's no smartphones, there's no Google, there's, if you wanted to search for things, you would go to a paper book called Yellow Pages. And computers only had probably just one core at the time. And, the internet was still in its infancy. And if you really wanted to connect to the internet, you had to plug a phone cable to a modem part in your laptop or computer. So it was the very beginning of the era that we're living right now. In 95, Windows 95 came out. And with that, Internet Explorer 1.0, yeah, that was the icon. And Netscape Navigator 1.0. These were the first browsers that actually had the 1.0 version because the internet was starting in that year. Before that, it was a lot of experiments, something was already there, but really not that much. Applications, because the internet was in its infancy, applications were not web applications, they were desktop applications. And so the whole world was actually built in this way. For developers, there were no IDEs. You had to open like a text editor to code in it. And, the main languages were C and C++. And they were great, even at the time, but they were complicated in a way. And so when Java came out that year, it was kind of a revolution because the Java platform was put out by Sun in the middle of 95, but the Java language at that time was still 0.9. And so it was a revolution because it was not only a language, it was a whole platform. It was composed of a language and a Java virtual machine. But not only, it was multi-platform. You could write the code once and be able to deploy exactly the same code in Windows and then on Linux, on a Unix machine for production. So you could develop on Windows and then practically doing nothing more, creating your jar, putting the jar into a Unix machine in production, and it would work. And this was a revolution. Before, with C and C++, you couldn't do that, because if you were developing on Windows, well, then you had Windows-specific system calls and operative system calls that you cannot port on a Unix machine. So you had to do ifs and defs in your code. And the tool chain to be able to compile on Windows and then to compile again for Unix or Linux was complicated. The other incredible advancement that happened with Java was automatic memory management. So you were finally free of the malloc and free nightmares that you had with C and C++ and memory leaks. Finally, you could do something like new object and then not even care who was responsible to deallocate that particular object, because the garbage collector was doing it for you in a precise way to never crash your program. Crashes of C and C++ programs at the time were the worst nightmare of anybody. But not only, it came with a very comprehensive library. At the time, C and C++, if you wanted to write, for example, a stack data structure or a vector data structure, there wasn't a standard library for C and C++. For C++ was probably, starting exactly at that time, but Java came with fundamentally a comprehensive library. You could do data structures, and every data structure, or most of them, were available. You could do user interface application. You had AWT and later Swing, where you could build applications, starting from whatever, downloading Java, and then you had a comprehensive library to do that. But the really major breakthrough that Java brought in was threads. Because again, before, you could only do threads in a very specific way, because in Windows you would do it in one way, but on Linux and Unix you would do them in a different way. But with Java, you could actually allow developers to start a thread in a very easy way and start writing multi-threaded programming, even if at the time it was not possible to run in parallel because CPUs were single core. It was still possible to run them concurrently. So that was really a breakthrough. And lastly, because of the times, and the internet was taking off really fast, Java had to have browser integration with applets. And that was another breakthrough, because you could download your application into the browser. The browser could just call the JVM and say, hey, render this application. And then in the browser, you would have your Java application running in it. So imagine Java, this platform comes out. It's all designed for the client side, desktop applications, browsers with applets, etc. Except there is this one guy in Australia that said, well, because Sun at the time exited with this new platform, Sun created a contest and said, okay, I have this new platform. I want to put up a contest where I would like people to write the coolest application ever, and then I will give a prize to the best application. So this guy in Australia, Greg Wilkins, starts thinking, say, oh, what can I do? Rather than writing something for the client side, why don't I do something on the server side? I have browsers. If I am able to download HTML to a browser, I can actually write a web application. And so I said, okay, let me write an issue tracking system for a web issue tracking system. Well, but wait a second. I do not have a web server. There was no Java web server at the time. So let me write a web server first, and then on top of that, a web application for issue tracking system. And so Greg Wilkins did exactly that and created the Jetty project. Sorry, this is a bit of a plug-in because I work for the Jetty project. But this means that the Jetty project is as old as Java, because Greg Wilkins wrote the first version of Jetty with Java 0.9 in '95, when Java came out. And this paved the road for the flexibility of Java, because it was built and thought for client-side stuff, but it was good on server-side too. So was it perfect? Well, not really. At the very beginning, Java got this tag of being slow because it was interpreted. The bytecode was interpreted. And so, yeah, but the good thing about Java is that it was continuously improving. Every single month year that was passing, Java went from 1.0 to 1.02, to then 1.1, and then 1.2, and so on and so forth. It was continuously improving. And in those years, 3 things came out that were, again, groundbreaking. RMI, the capability of calling a method and having this method basically go through the network into a different process, doing stuff over there and coming back as if you were calling a local method. That was basically magic, because you were calling a method, but it was actually going elsewhere and coming back, and there was almost no difference. The second thing was JDBC, which seems incredible right now, but again, at the time, there was no standard way to access relational databases. You had to, find some kind of library that was doing this for C and C++, but Java had it in the standard library. So every developer had a common language to agree upon on how to do things. Oh, you're doing database? Oh, you're using connection in this way? What connection pool are you using? And it was all common because we were speaking the same language, as in we were using the same standard library API calls. And so we knew what we were talking about. And the third thing was reflection. Now, if you think about it, how would you do reflection in C and C++? It's possible, obviously, but it's difficult. But you could do this in Java. You had, finally, a standard library. And reflection seems to be, okay, but, But it paved the way, for example, for web frameworks that were starting at the time, because you could build an object, and now everybody says, okay, I can do object dot something in a string, and then it gets interpreted, and you can do that only if you have reflection available. So, big improvement. What else was slow at the time? It was C and C++ compilers. I remember my first job in Israel. We were working during the day. At 6 o'clock in the evening, you had to push all your work into the central repository, and then the build was starting, and it was lasting the whole night. It was compiling the full project, and it was lasting the whole night. Because C and C++ compilers were powerful, but they were really, really slow. Cliff Click is an American programmer, and in 1995 wrote his PhD thesis. And he said, this guy has been writing compilers since he was 15 years old. And he knew the compilers were slow, but he wouldn't listen. He would say, I can do better. And for his thesis, he basically wrote a compiler that was n times faster than all the compilers of the time. And even though everybody around him was saying, compilers are slow, what you're doing may not be of a big difference, in fact, it was a revolution. Because then, Cliff wrote the C2 compiler that was later integrated in year 2000 in Java 1.3. And with the introduction of the C2 compiler into the Java virtual machine, Java was now fast. Slow wasn't there anymore. Now Java was compared to C and C++ performance, and it was a revolution again, because now you could really write simple things with a simple language that was not as complicated as C++, but now that was a revolution. At the same time, Sant underwent like a big project. They had the Java virtual machine before for Java 1.1 and 1.2, but for 1.3 they said, no, there's a better virtual machine over there. Let's buy the company that built it, and let's use it for Java. Imagine who wrote the initial JVM called, at the time, well, it's called Hotspot now, and everybody knows about this. But the guy that actually designed that JVM was Lars Bak, which I don't know how many of you know it, but Lars Bak is the name famous for the V8 JavaScript engine. This guy was able to build the virtual machines in his sleep. And this Hotspot Java virtual machine, even if it is the Java virtual machine, is actually a brainchild of his mind as well. Fast forward 4 years, and then Java 5 comes out. And it comes with, again, few improvements, small improvements that, as a building blocks, you're building the house brick by brick, but eventually you get a very nice house. It comes with generics, with annotation, and with another one breakthrough of the technology in our field, the memory model and atomics. At the time, multiple core were starting to appear, and so you could have in 2004 a laptop with maybe 2 cores, and certainly this was happening on the server side too. And so what was going on at the time is that you could not write a program that was behaving properly for a particular processor or a particular operating system, because the compilers, GCC and so on, didn't know how exactly, what was the memory model, what happens when I write this variable and there is another thread concurrently reading that variable. That was not defined at all. You could write something for a specific processor and a specific operative system, but that was very tricky. Here comes Java and says, nope, we have now a set of rules that explicitly say exactly what should happen, and we have now atomics that allow programmers to write nice things using atomics. Imagine, there were no atomics in no language at the time. So if you wanted to write an atomic integer, you had to go to assembly for that particular processor. In Java, you could do it with the Java class, and that was a revolution again. Fast forward, And in 2011, Java 7 comes out with Invoke Dynamic, because Java took on the challenge and said, oh, why don't we integrate dynamic languages like JavaScript, Ruby, Python into the Java language? I could take a Ruby or a Python source code, I can compile it into bytecode and have the JVM interpret that bytecode and actually run it. Even if the language is very dynamic and can do, crazy stuff like JavaScript can, right? Invoke Dynamic was introduced in the language, and it just so happened that the designers of that particular feature were so smart that the same feature that introduced dynamic languages in the Java platform was later used as the cornerstone for implementing lambdas. And that was mind-blowing again. And this tells a lot about the geniuses that are driving the Java language forward. Super fast forward to basically 2 years ago, and Java 21 comes out with other two groundbreaking features. One is virtual threads, and the other one is generational ZGC. So virtual threads are great because they basically break a very old problem that every language has, which is the difference between asynchronous functions and blocking functions. With virtual thread in Java, this is a groundbreaking feature. We can now have the capability of running a blocking function in a very efficient way, because virtual thread will basically arrive at the stop point, being it network I/O or lock contended or something like that. They would stop there, but they would release the carrier thread so that the carrier thread could do other stuff. No other language has this feature. There are similar features, like in Go, you have Go routines, or you have async await in JavaScript and similar things in languages. But async await and Go routines and so on, they work similarly to virtual threads, but not exactly, right? A virtual thread has the special feature that when it arrives at blocking code, it knows to stop but release the carrier thread, which is a feature that, as of today, probably only Java has. And again, groundbreaking. The other one is generational ZGC. Java was kind of always having this problem of, well, a garbage collector will eventually stop for little pauses, but those little pauses may become longer pauses, and they would entirely stop the application. Now, ZGC implements an algorithm that allows you to have sub-milliseconds stop the work pauses for your programs. Basically, you don't see them anymore, right? Sub-milliseconds is just as if they didn't happen. So this would solve the generational and the garbage collection problem. What is it in the future for Java? Well, for one, it will probably continue with the backward compatible characteristic that went from 95 up to today. You could actually take a program written in 1995, put it into a today JVM, and it would run. But that not only applies to programs, it applies also to the skill set that a Java developer has. Because you could learn Java, and you're almost certainly, it would be possible for you to basically continue working on the field. Even if the Java languages evolve, you can keep up with the language. But even if you don't, well, then your skill set is still valuable, because even if you have an old skill set, you could still write Java programs that runs in today's modern JVMs. But in concrete, what do we have? We have Project Valhalla, which will introduce nullable and value types to the languages. There are already previews in Java 24. This is going to be great because it's been 10 years and plus probably in the making, but eventually they made a really big breakthrough recently, so that value types will probably arrive very soon, and again, they will be a game changer. Another thing would be Project Lilliput with small object headers, which seems another of those small bricks that you put in your house. But this will be such a huge performance influence, because the smaller you can get your objects, You have now a cascading of effects into modern computers where more objects can fit your CPU cache sizes. You can do a lot more. You don't pay that cost anymore. And then from there, you have a lot of additional and cascading effect on performance that will just be great. And the last project that I've been talking about will be Project Leiden, which is all concentrated in giving Java a really, really fast startup time so that you can spin off a JVM really fast, maybe run a little bit of code, and then shut down the JVM and then be done with it. OK, so that's my story for the 30 years of Java. I guess I'll see you in 10 years. See ya.